This is differential equations. We're doing activity 611 part E. So here we have a hyperbolic tangent function called, some people call it, you can call it cosh. It's really hyperbolic cosine. And you can sometimes use an integration table with hyperbolic cosine, hyperbolic sine, but they're not always included. So we're going to use this integration table. So we're just going to have to break down hyperbolic cosine into what it is. So I'm going to rewrite f of t equals 2t squared times, and then hyperbolic cosine is e to the t plus e to the negative t over 2. Well, that 2 is convenient. It cancels out. So that means f of t equals t squared e to the t plus t squared e to the negative t. Okay. Now we take a Laplace transform. So Laplace transform, fancy L of f, that's a new function. And then we're going to use, it's defined on numbers, s. We're assuming s is greater than or equal to 0. So Laplace transform of f of s, that's equal to the integral from 0 to infinity of this function times e in negative st. So t squared e to the t plus t squared e to the negative t times e to the negative st dt. Okay, so we simplify, or let's expand it. I mean, t squared e to the negative st. Should I write it a different way? Yeah, I think I will. Equals integral 0 to infinity t squared e to the s, no, factor out of t times 1 minus s plus t squared times e to the t negative 1 minus s dt. All right, now we're going to have to use this guy twice. So first we use, so each of these is with a different a. It's going to be hard to keep everything in check. Keep track of everything. So basically t is x, and then our a will be different. It might be 1 minus s, it might be negative 1 minus s. And so I'll do each of these integrals separately. So then we'll have t squared times e to the t times 1 minus s all over a, which is 1 minus s from 0 to infinity, and then minus 2 over 1 minus s times the integral of t times e to the t times 1 minus s dt, plus, I'll do it with the other term. Oh, you can't see this, I'm sorry. T squared e to the t times negative 1 minus s all over negative 1 minus s, 0 to infinity. Oh, and there's 0 to infinity here. Minus 2 over negative 1 minus s, integral 0 to infinity, t times e to the t times negative 1 minus s dt. That seemed like the best way to keep everything in order and not forget any terms. Which means I'm going to need to grab another piece of paper over here. All right. So these terms are 0. They go to 0 when infinity goes to 0 as long as, what condition do I need? I need 1 minus s and negative 1 minus s to be negative numbers. So in order for them to be negative numbers, so for 1 minus s to be a negative number, s has to be greater than or equal to 1, and s greater than or equal to negative 1. So s, both of them, s is greater than or equal to 1, by the way. Okay. Now, otherwise, it's undefined, goes off to infinity. All right. So then forget about these terms. They both equal to 0. And now I'm going to integrate here. So then I get here we go. Negative 2 over 1 minus s times and then it goes t times e to the t times 1 minus s all over 1 minus s. So this is from 0 to infinity minus integral 0 to infinity. Oh, I forgot my, I'm just going to restart this line. Okay, so equals negative 2 over 1 minus s times, and then, so I'm taking the integral, I'm doing this integral first. So the negative 2 over 1 minus s, and then I'm using that integration table. So that means I have, my first term is t times e to the t times 1 minus s all over 1 minus s, 0 to infinity, minus n in this case is 1 over 1 minus s times integral 0 to infinity of e to the t times 1 minus s dt. And then minus 2 over negative 1 minus s times t e to the t times negative 1 minus s all over negative 1 minus s, 0 to infinity, minus 1 over negative 1 minus s, integral 0 to infinity, e to the t times negative 1 minus s dt. Still assuming s is greater than or equal to 1. Okay, these terms, they go off to infinity, or as t goes to infinity, they go to 0 as long as s is greater than or equal to 1. And when you plug in 0, they're 0. So forget about them. And so I'm left with, so this equals, so you're left with 2 over 1 minus s squared times integral 0 to infinity e to the t times 1 minus s dt plus 2 over negative 1 minus s squared integral 0 to infinity e to the t times negative 1 minus s dt. Okay, so then we get, here we go. Integrating this, we get 2 over 1 minus s squared times 1 over 1 minus s e to the t times 1 minus s, 0 to infinity, and plus 1 over negative 1 minus s. Well, first it's the 2 over negative 1 minus s squared times times 1 over negative 1 minus s e to the t times negative 1 minus s, 0 to infinity. Okay, so as t goes to infinity, that term will 0. So you're left with equals negative 2 over 1 minus s cubed plus negative 2 over negative 1 minus s cubed. There you have it. That completes that problem.